is Rebecca Zane, but you can just call me Miss Zane. And I just want to ask everyone a real quick question. Has anyone ever been on a roller coaster before? Raise hands. Oh, we got the majority, but if you haven't, we are going to go on a quick virtual field trip to Cedar Point in Ohio. Has anyone been there? So fun. And so we are going to virtually ride the Millennium Force roller coaster. So if you could just buckle up, get ready. We're going to get going here, and here we go. Feel free to put your hands up. Keep the screaming to a minimum, but you know, it's going to be a fun ride.
I love this roller coaster. Like I would not have my hands up right now. No, this is being yes. Like I would not have my hands up at that time.
So fun. So that was just a little short field trip, and now we're back in our classroom and ready to learn. Can I get a thumbs up if everyone's ready to learn? So today we are going to be talking about energy. Can everyone say that word? Energy. Thank you. Good job. And so, does anyone have any ideas of how energy might be related to a roller coaster? Well, perfect. I'm glad you're all here today. Here we have, I'm going to give you a little packet of super duper fun worksheets. Everyone can take one. And on the front is a picture of a roller coaster, much like you have just experienced. So, could I have a volunteer to read the directions on the bottom of the first page? Becca.
Label your predictions of where potential energy occurs with a P and kinetic energy with a K.
Okay, so now we're going to have to go back in our brains, see if we know anything about potential energy, kinetic energy. We're going to talk about them, but I just want to see, what do you predict? In which squares do you see potential energy or kinetic? So you can mark those with a P and a K.
It gets on our beaches and in our water until there's nothing left to do. We can't stop it.
We're going to take about 15 more seconds.
Are starting to mistake this
Get
trash
your
for
predictions
food and
down.
are poisoning themselves on the litter in pollution.
Okay, everyone. So now we are going to make our own kind of energy. So you're going to need your supplies that are in your bags at the middle of the table.
Oil companies don't
And
even
each
realize
table
that
is going to make their own
they do.
spool
They don't
racers.
even care.
So if you could just take out your materials.
Polluting the oil and harmful chemicals, killing our oceans, making them unusable.
So our picture directions aren't working, but we are going to do it together as a class, and I'll be with you. So the first thing you need is your rubber band. So can someone hold the rubber band? Very nice. And also your toothpick. So you need these two things right now. What we're going to do is take our rubber band and make a little loop. So if you could hold it like this in the middle. Does everyone see that?
Is it inside the rubber band?
No, just on top. And then we're going to sort of weave that through. So take one side and loop it under the other. I had a picture directions, but it's not pulling up, so we're just doing it verbally. So did everyone see how I did that?
Yeah, that's what
One side and through the other. Yep, it should look like a little U. Looks like everyone has it. Very nice. And now we're going to need our spools, which is this wooden block. Everyone have their spool? maybe pass it off to a friend to do this next step. And we're going to take the end of the rubber band that's not on the toothpick and push it through the middle of the spool so it comes out the other end and pull it through. We're going to have to use our hand and tell me one thing that they pull it through. So it should look like this. Your toothpick should be right on the end.
Good job. Glad that you got that out of that video.
Does anyone remember straight direction followers?
Becca, you might be able to thread it with your toothpick.
We have some suggestions.
Well, there was a picture
Just stick the toothpick right through and hold the other side.
That is a great idea. Thank you, Jess.
Take any guesses?
Is everyone ready?
Because I was
It just really came off the toothpick now.
Oh, okay.
And it is
So,
very difficult.
it should look like this. And if you are at this step, go ahead and take a small piece of tape
And in
and tape the toothpick to the spool. Just so it doesn't come undone.
This is small.
It says oil spills
Wait, no more. The other way.
of Alaska in 1989 were the ones from the Gulf War in 1991 affect a lot of the eggs. So these spills are only small.
Okay, once you have that taped, we're going to break off the ends of the toothpick just so it rolls a little bit faster. See? We're going to take one end, just break it.
Tanker spills contribute about
And the other end,
the remaining oil gets in the water.
take those off. Make sure it's still attached though. Very nice job.
The most disturbing fact is that at least 40%
Can I get a thumbs up if you're ready to move on? Oh, we have some thumbs down.
I got this, guys.
Okay.
We're ready.
Once you have that done, you're going to take your rubber band end and your little washer. Does everyone see this little metal circle? You're going to also thread that through. So it's on the other side of the spool, not on the toothpick side. Just so it stays in place really nice for you.
Some oil spill
Okay.
can be as damaging to the environment as the oil
Last
itself.
step, we're going to take our pencils
Pollution is easy to clean up, as we have learned.
and put it through the loop.
Really difficult. So you're going to find out how hard it is to
Wrap it
actually
around
do the
so
work.
it just stays on
So I'm gonna
really
pass
nice
it out
like that.
to each group.
It has a little circle.
Little baggie.
Did everyone see how I did that?
And inside the baggie there's a little bird.
Okay, so here comes the fun part. We're going to take turns in our table winding our
Each person
pencils
is
like
going to
this,
get a cotton ball
like so,
and a piece of string.
and
And each person
set the spool on your table,
each group will
let
get
it go,
a bird.
and see what happens.
And so,
So,
first what we're going to do
go
to
ahead.
create the oil spill is we're going to take
Keep
one of the
winding.
droppers in the bag.
As much as you think it needs
Do
to
you
be
take the
wound.
pencil out?
No, you just put it on the table and let it go. So make sure everyone takes a turn. Here's some things to think about while you're turning it. Does the amount of turns I make affect how far it goes or how fast it goes? As you try to turn it just a little bit and maybe like a lot. It doesn't break. But so make sure everyone has a turn.
Stop. There's like.
And you have your own little spool eraser.
Why do you open that?
So if you have any spools of thread and these simple objects at home, you could even make these at home, race your friends.
Less days.
Yeah, so we can
Okay, is everyone raced? Did everyone do it? Okay, now I'm going to ask for some super special learners. Can I have everyone's
now we're
attention?
going to try
Thank you.
to
Some super special learners to think really hard about where can we see potential energy in our activity? How did we make potential energy? Stephanie?
When you twisted the pencil, making
Yes.
the rubber band.
You created potential energy energy that builds up, and it then converts or transforms into kinetic energy, which is like moving energy. So you spun, you wound it up, created potential, let it go, and it turned into kinetic, and that's how it rolled on the table for you. So, did anyone make any observations if winding it up more made it go faster or longer? It did. Does anyone know why that might be? Why did winding it more, Stephanie?
Because you tightened the rubber band so it went longer and faster to unlock the rubber.
Yes, you created more potential energy that could be converted to kinetic. So that was very good.
Water spills. So you can dip the bird's feathers
Okay.
into oil spill.
Our next activity is you can
If you want to feel the feathers like
just pull your rubber band out of the contraption. Just sort of undo it because we need the rubber bands for the next activity. So, and you're also going to use your ruler for this next activity. Okay, does everyone have their rubber band and their ruler? All right, so we're going to flip to our second page of our little packet.
So what happens to the bird's
We're going to practice like good scientists do and record some data. So if everyone has their ruler and their rubber band, you're also going to need your paper and a pencil, and everyone can follow me into the hallway.
another oil spill? So go ahead and grab and drop it.
Do we need to
Add
take
a cotton
Oh, just the
And the pencil? Yeah.
lines here. Every table should have a line. 4 lines. Every table has a line. Is everyone out here? Here be it. Okay, so and you can put down your guide sheets while we use the rulers and the rubber bands. And can I see someone for an example? So what does the first box say? How many inches are we working with here?
4.
4. So what you're going to do is hold your ruler out like this, start at the top before it says 1, and pull it so it reaches 4 inches. Does everyone see that? That's where our 4 inches comes into play. And then we're going to get behind the line and release it. Woo! So everyone from each table is going to take a turn releasing with 4, 5, 6, and 7 inches, and we're going to see how far it flies. So here is yours.
Thank you.
So our first round is going to be 4 inches. So remember, start at the top, pull down to 4, get your launcher ready,
Don't hit a list
and
up.
let it fly.
Whoa.
Woo!
I don't know which one.
It's the one closest to Rebecca.
Very nice. So can
Find the
anyone make
shorter
an
one.
estimate of how far that went? That was pretty far, guys. It was. Can I borrow your ruler?
Yeah.
Let's just see how many rulers lengths that was. Can you count with me, everyone? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Was it about 10? I think it was about 10. So we can write 10 rulers. That's how far our rubber bands flew with 4 inches. And now we can rotate in line. The next person can come on up and try to do 5 inches this time.
Doing centimeters.
When you're ready, you can let it fly. 5 inches.
Whoa. Ours is the exact same.
Can anyone do some comparisons? Do you think it flew longer,
Further.
further with 5 inches than 4 inches?
Yes.
And why would that be?
Because
energy, which releases to kinetic. Okay, we can switch. Does anyone have an estimate of what that might be? If our last one was 10 rulers.
15 rulers.
15, that sounds great. Let's write 15 rulers.
Like 12 guys.
And our next person is going to try 6 inches. Let's see the results.
She's in the wrong place. Boom!
Are we letting go?
Are we going?
Yeah. Very nice. You can collect. If you think it went further, give me a thumbs up. If you think it was shorter, a thumbs down. A lot of our class thinks it's further. You are right. Even more potential energy. Any predictions or estimates of how far that one went? Back up. 20. 20. That was perfect. You can write 20. And one more. Kevin.
You're in the line 5.
Oh, I'm sorry. Okay. Ready? Set? Go.
Whoa.
That was a strong 25.
Farther or shorter? Farther.
It came all the way.
We got some farther. Very nice. Did anyone not get a turn that would like a turn? We all got to experience how that felt, pulling it back and releasing it.
Feels great.
Okay, now everyone can take their materials and go back to your seats.
Give me 8 minutes.
How do you like the lesson? The lesson's great. So good. So good.
Okay, so once everyone gets to their seats, we might want to write some jottings about some patterns that we see. So, can I have a volunteer to take a stab at what kind of relationship did we see between how far we pulled and how far it flew? Becca?
For every 1 inch, it increased by 5 rulers.
That is some good math skills. Very nice. Can we give Becca some snaps? That was impressive. Any other ideas?
Yeah, so if you
Some general, did it go farther the more we created?
all waves, it would just spread over a
The more
larger
potential energy we created, the more kinetic energy.
And then if you also think about
I
all
like
the
how you use our science terms. Very nice. So you can write down 3 jottings there, and when you're ready,
so it'd be easier for them to work
we
in nicer
will
weather
move
conditions.
on.
And the last one, where would the oil go in a real ocean? So if there's a real oil spill.
So now, we're going to revisit our good old roller coaster. Can I get a volunteer to come up?
And then also,
And let's try to label this now that we have some more information, Stephanie, about potential and kinetic energy. So our potential will be the P and our kinetic is the K.
does anyone know any other types of pollution?
Do all of them and we will.
Land pollution, any other than land? Air pollution. So pollution happens in the environment in 35 ways. Litter off the side of the highway.
Very nice, Stephanie. Could you explain to us what you wrote here?
And a type of pollution, it can happen.
Why do we see potential energy right here at this top?
Because at the top of the roller coaster, you have the potential to go down the roller coaster. And when you go down, you're moving, so that makes it kinetic.
Yeah, so even though there wasn't any box here, we are creating potential all the way up here. Potential, potential, potential. It reaches the peak and then kinetic, kinetic, kinetic. And it reaches, and then we start back. Potential, potential, potential. Very nice. Does anyone have any questions about our roller coaster? No? Okay. Now, we're going to think, yeah, we go to roller coasters maybe a couple times a summer. But where might we see potential or kinetic energy in our daily lives? Stephanie?
Riding a bike down a hill.
That is a great example. Could you explain where the potential kinetic might be?
Potential's at the top of the hill before you start going down it, and when you go down it, it's kinetic.
That is so awesome. I'm so glad you brought that to the table. Does anyone have another example?
And before
times a little bit because our last thing, you can take out your cellular devices if you would, and we are going to participate in a poll. Can anyone tell me what a poll is?
Oil tanker.
Any ideas? Maybe if I bring up the website, you will be reminded.
We have this.
Alyssa?
It's where you can vote.
Yes, exactly. So, if you would, you can text Rebecca Zane, 038, to 22333.
Is it
The
all
question we're answering is, what is one place you can observe potential and kinetic energy in your daily life?
Is that all capital?
Yes.
Okay.
So you can build off of what Stephanie or Becca said, or you could try to come up with your own. As our responses enter, we will see them appear on our board. We can share in our thinking all together. Yeah, it'll say you joined, and then you can type your answer. It's okay if it's just a couple words. Yeah. Yeah. Once you join, just type your answer and it'll come up. Hopefully.
Why is that?
Oh, computer. We have some ideas for me.
Okay, I think I see two more places. Wait. I don't know. The middle one?
The top, middle,
Top, middle, bottom. So the first one,
everyone some more time.
how was the art on water side? And then the sewage plant, which is really musty rust color of the water.
Those are all just different letters.
So here's a chart.
We are creating a word map, but if we want to see it in a different. I just cleared it. Some answers that we had were a pen and a spring. So can anyone elaborate on what that might be? I'll demonstrate while you dictate what I'm doing. Alyssa? So, see how that just jumped right up like that? There is a spring inside your pen that makes it do that and creates potential and kinetic. We have a pogo stick. That is awesome. When you push down potential, kinetic. A trampoline, another jumping idea that is very valid. Does anyone want to share their idea now that we have some more thoughts flowing, some help from our peers? I think all of the ideas that we shared were really, really great. Okay, just a quick recap. Can anyone raise their hand? What is potential energy? Everyone should know. Anyone? Yes, it is stored energy.
Does anyone want to share?
And what does that turn into? What is the next kind? Randy? Very nice. Do you want to define that, or you can call on a friend? Do we have a friend who can help her out? What is kinetic energy? Stephanie.
Kinetic energy is when you're moving.
Very nice.
We keep riding the roller coaster.
We could keep riding the roller coaster. That is a great idea. Here we go.